So this one is for you .NET developers. If embedded development looks hard, tinkering with little tiny things and hardware and actuators and sensors, we have something for you. Chris from Wilderness Lab is here to introduce Meadow and how you can use the full .NET stack onto embedded devices. That's today on the IoT Show. Hi, everyone. Thanks for watching the IoT Show. I'm Olivier, your host, and today I'm joined by Chris. Chris, would it be fair to call you a veteran of both .NET and embedded development?
I would say that's a fair statement. I've been thinking about it for a little while, and I think I've been doing both for over 20 years.
Yeah, which doesn't mean you're old, right? We're not old. It's not because we've been doing embedded development for so long.
Yes, my children, I'm old.
True, for mine too, actually. We're kind of outdated dinosaurs. Anyways, we're still here to teach them some cool stuff about development. So that's it, right?
Yep.
So you're here to tell us about this weird intersection between .NET and embedded development. And you work for a company called Wilderness Lab and an interesting platform called Meadow that we're going to talk about. You're going to demo today. But before we jump into that, can you give us a little bit background about yourself? We've just mentioned the fact you've been in the embedded space for some time now, .NET as well. But
sure.
Tell me more.
Sure. So I've been doing embedded development for, like I say, over 20 years. I started out as a VB developer and got more and more interested in how does hardware actually work, and basically self-taught all the way down to being able to read and write registers. And I worked at a single board computer manufacturer. Then I helped found OpenNetCF for those who know the compact framework. So I've been doing it for a long time. About 3 years ago, I joined Wilderness Labs. 4 years ago, a couple of people that were originally with Xamarin left Microsoft once it was acquired, and they decided that embedded development needed to also be an easy thing for .NET developers. So they started Wilderness Labs with the focus on the Meadow product.
That's interesting that the people who wanted to bring mobile development to .NET developers or .NET to mobile development, not sure which direction, but they're the same one we're trying to simplify embedded development for .NET developers. I find it pretty interesting.
Yeah, it is interesting, and they're really passionate about doing it.
Yeah. So what are the key challenges for a .NET developer to approach embedded development?
Sure. So typically a .NET developer, they're using a high-level language, so their semantics are usually not for low-level things. Embedded developers like to talk about registers, they talk about interrupts, a lot of things that .NET developers just don't even think about. So there's this strange intersection where you have to be able to talk to interrupts, know how to read a data sheet and what it looks like on silicon, how to read schematics, use a scope, things like that, which are skills that most .NET developers just don't have because they don't need them in a day-to-day using, for desktop and server and that type of thing.
Yeah, but they don't need to think about these because the framework does it for them, right?
All that away from them. Yeah, that's the goal, right? Is to make it easier, to make it faster to develop so you don't have to understand the fundamentals and all of those low-level things that make the computer or the T in IoT work.
Yeah, but we'll talk about that. But there's still some things that you need to approach a bit differently, even though you have the abstraction layer, because you are on a platform that has limited resources still. And so the infamous, for example, garbage collector of the .NET framework is something that is very practical, because when you're a developer, you create instances of objects, and that in the background use memory. And you don't really have to care about it because you're running on a server on a big PC with lots of RAM, and then the framework will clean it up for you. But we'll see that it's not exactly the same for embedded development. Even though you have the framework, you still have to think about it a little.
Yeah, absolutely. The garbage collector is a great thing. a lot of the features of the language, you don't have to worry about memory leaks and pointer overruns and things like that. And that is wonderful. The speed with which you can develop in C# or VB or F# is much, much better. But there are still things that you have to keep in mind when you're working on an embedded platform, such as how much memory you're using and how many objects you're building, just for performance.
So what has changed? Because we were saying that for embedded development, you need to understand these notions of memory management, registers access, hardware access, and so on. And that, you didn't get to use a huge abstraction layer like the .NET framework. There are some frameworks out there, but what has changed since then, since a few years ago, that now allows this kind of frameworks to come on this microcontroller world?
So we're kind of at an inflection point. Silicon and microcontrollers have been getting more and more and more powerful, and the cost on those has been coming down. And then Microsoft has been doing a lot of work. Mono has been moving up in capability. So it's kind of the intersection of, we've got all of this hardware that is getting better, and Mono is becoming more and more able to target lower level hardware and ARM architecture. So it's that inflection between the two that's really gotten us to where we are today.
Nice. For those who don't know, Mono is a version of the .NET framework that has been designed for mobile devices, right?
Yeah, it's I guess you could call it a port of the .NET runtime pieces for ARM architecture, but really the lines, especially in .NET 5 and 6, are getting very blurry between what is Mono and what is .NET Core.
Okay, so let's look at how that works, right? I'm a .NET developer, and I want to do development of an embedded device. So, but what I know is I've got a UI, I've got an app that eventually has buttons and things like that, display stuff on the screen, and I want to transfer that skill set to embedded, where I'm going to have a physical button, I'm going to have an actuator of some sort or something like that. So,
absolutely. Let me show you a very, very simple example of this. So here, let's say I've got an application idea that this is really simple for a desktop developer. I've got a button that I'm going to click. And when I click on this button, I'm going to have some action. We'll have this flag rotate from down to up. Real simple.
Real application that I die to have on my PC right now. Right?
Absolutely. It's one everybody is just dying to build.
Yeah, totally.
So you build your form, and then on it, you're going to put on the image, the bitmap. But the important thing here is we use a button, which comes from the framework. We add a click handler to it. When we get that click, we call an action, which rotates the flag. And in this case, the rotation just moves the bitmap, right? So we run this, real simple. Nothing rocket science here. We click it, we get a rotate, it goes up, goes back down.
Yep.
It's something that any desktop or web developer would understand.
Perfect.
So if we take that same paradigm to an embedded application, here's the Meadow application, and keeping the same method names, things like that, what we have is we've got a button. So in this case, it's a push button, and it's a physical thing. Let me bring up what this looks like. So I've got a push button here, and this is two separate Meadows here. And then I have a servo. The servo it's effectively a motor. Here's an example of one right here that we can do that rotation.
Okay.
So we've got a push button and a servo class. These come from the Meadow Foundation library, which is open source. It's got something like 130 or 140 different peripheral drivers in it. So we just create an instance of a button and a servo. The button, just like you would on your desktop, we're going to add a click handler. When the click happens, we're going to call rotate flag, and inside of it, instead of rotating an image, we rotate the servo. typically when I'm developing, when I do hardware, the first time I'll do it on a breadboard, which allows you to just stuff the wires right down into these holes. They're real easy to set up. And then I push the button. I can find it. And then it rotates this little flag.
Nice.
The challenge with breadboards, at least for me, is oftentimes, especially when you get more wires on it, sometimes the connections get a little flaky. So I like to solder things together once I kind of have it working.
Yep.
So here I soldered one together and actually 3D printed something, but it's the exact same thing. The wires are just on this board. If I push a button, the flag comes up.
Nice.
And the flag goes down. I should have printed it in a different color, but it's that simple.
So, it is, right?
Yeah, we're really just taking the idea of user interaction causing some reaction of the software. And in this case, it affects hardware directly. But otherwise, it's the same thing.
And what we saw here is that the API, or the way developers interacting, with the hardware, with the resources, I would say, is the same, right, in both worlds. Because Meadow, as a framework, abstracts the access to the underlying hardware, as in, the I2C buses, SPI buses, UART, and so on, right?
Yeah, it abstracts it, and it abstracts it well enough that, for example, this is running on an STM32 processor. Mm-hmm. You can take this exact same application, and we have another implementation that is called Meadow for Linux. You can run the same exact thing on a Raspberry Pi, and it will do the same thing. You can plug it into, the pins are obviously in a different location for the I2C or SPI bus, but the peripherals and all of the code is identical.
Okay. And so you just mentioned Meadow for Linux. So Meadow for Linux to go onto these like Raspberry Pis and other types of systems. You want to use .NET there, perfect. But Wilderness Lab also offers a deeper integration with hardware, right? So you mentioned Meadow, or pointed to the device here saying Meadow. So it's not just a framework. Is it also hardware?
Yes, it is also hardware. So this is the Meadow F7. It's an STM32 and ESP32 combined. It allows you to have Bluetooth and Wi-Fi and things like that. We also have a core compute module that has actual Ethernet, some things like that, and different products for development. But so yes, Meadow is both a framework and we've got hardware as well.
And that means that, as an enterprise, if I wanna have support, that's a solution that goes beyond just, the piece of software as an open source thing that I can just use. You guys will support, the hardware will support that integration and so forth, right?
Absolutely. The hardware itself is production ready, and you can design hardware if you have a specific application. So we've got customers that are using it for actual industrial applications like water treatment, things like that, that these boards, the F7 ones, can be surface mounted directly as they are as a module.
Okay. And you mentioned that the framework itself already has support for a bunch of different types of drivers, so meaning different types of hardware, like chips and others. So if I were to, and I guess we'll send a link to the actual resources, but if I were to add my own hardware support, like, is that something that's doable, and how is that?
Absolutely, it's very doable. So Meadow Foundation is our collection of peripheral libraries. And like I said, I think we've got somewhere around 130. My personal goal is, if you can go to SparkFun or Adafruit or somewhere like that and buy a peripheral, we want to have a driver for it. But if you find some hardware that we don't have a driver for, it's real easy to pull down the code that we have and take a look at those as examples. Most of them, we've got representative samples for most classes of peripheral hardware that you can imagine. If we don't have one, we have our public Slack. You can come and ask for support and get help. We can help you work on it. And in some cases, it's we have interest in doing these things. So some of our developers will oftentimes just, you say, oh, I would need a peripheral driver for this piece of hardware, and we'll just develop it for you.
Nice. That's fun. Just send a couple of coupons for pizza, and they'll be good.
Because it's so fun to do. We find that oftentimes we'll just do it because, that's an interesting problem. Let me go try that.
Nice. I love that. So I'm sure .NET developers are getting very excited here because tinkering with hardware is fun, but it could be daunting. It could be something that might seem a bit hard. And working with software in C, C++, with these tool chains that embedded developers are used to, it's not something that is trivial to ramp up and to learn, especially when you've been doing software with .NET for years. So I'm sure they're super excited. Before we let them go and play with all of that and give them a link to learn more, I also want to bring up some, not caution, but some message here, which is, and we mentioned that at the beginning, it's not because you have like full .NET APIs that you should not be careful of what you're doing, right? Because
absolutely,
when you're running on a server, you have infinite resources or almost, right? And so we very often don't really mind what we're doing with our software. But here you have specific recommendations for .NET developers in terms of what to do, what not to do, what to keep in mind when they're using Meadow in C# and developing their apps, right?
Yeah, absolutely. So the F7, which is on these, is comparable to like an old Pentium computer. So while we are running full .NET and you can go out to NuGet and pull in a reference to anything that NuGet has and it will compile, it doesn't mean that it will run or that it will run well. We are still limited on the amount of memory and the amount of processor that you have. So you can't go grab these gigantic things and bring them in, but reasonable, smaller sized stuff does work well. You also have to be aware of resource usage. You have to try to reuse objects. You can create a bunch of objects in loops, that will work, but the GC is going to actually penalize you for it. You're going to get lower performance as it's having to clean up and rebuild all of these things. So if you're reusing, it will give you a better experience here. But the reality is, if you're making better code that will run on a Meadow, your same code or your same skill set will improve even on a desktop application.
Yeah, exactly. That you will learn new skills or paying attention to details you were not paying attention to make your software even better somewhere else.
Absolutely,
right?
Absolutely.
And that's something that anyways, when you're doing embedded development, you're building specialized devices that do one, two things, right? They are very good at doing that, and they're optimized in terms of cost, in terms of bill of material for the hardware. And like your little Meadow device was just raising a flag. And at the end of the day, you designed it to do only that. The casing and so on is just for that, right? So
right. So a good way to think of an embedded application is it's really just a single process, right? You don't have multiple processes running in the background and doing a bunch of additional things. Absolutely, you can create threads that are doing some things in the background, but you can usually think of it as a single application or a single process as if you were writing it for the desktop.
Yeah, totally. Another tiny detail for embedded purists or real-time developers, we cannot do hard real-time with Meadow, right?
Correct. This is not designed for hard real-time. For those who don't know what hard real-time means, it means being able to guarantee that when something happens, a reaction will happen within a certain bound. And if you're doing things like motion control and things like that, or safety critical systems, you want things to happen within a specific time. If you've got a GC, it can pause whatever your application is doing for an indeterminate amount of time. So you can't get that type of behavior. So you definitely would not want to use it, though it doesn't mean that you couldn't have something doing real-time processes as another processor on the same board and communicate between the two.
Yeah, that's actually a very common scenario. You have the control system, which is hard real time, does the heavy lifting down there, and then you have the interface or connectivity part that is higher level and doesn't need to have this critical time real time support.
Absolutely.
Chris, fantastic. If people want to learn more, they can go to the website here, wildernesslabs.co/developers would be the page for all the resources for our developers here, right?
Yep, absolutely.
Okay, so have fun. .NET developers, go do some embedded tools project and tell us what you did. Just comment down there in the video, reach out, and we'll be happy to feature your projects. Chris, thanks for your time.
Thank you.
See you soon on the IoT Show.
All right.